Let us see a few examples of regular expressions. We have to note that when we form regular expressions, initially it can be in natural language. We can specify our requirement in a natural language, and using these three operators and the induction rules that we have seen earlier, we should be able to form a correct pattern that matches our definition. Let us see, take this example. Just take this example. Here, our alphabets are A and B. Now, what about the expression A or B? It says that the language can contain either a character called A or B. Essentially, it is a set AB. So every RE has an associated language. See the second expression, A or B followed by A or B. We are concatenating here. There's a concatenation operation. So here we can see that there are two operators here now. In the first sub-expression, you have a OR operator and it is followed immediately by a concatenation operator. Now, how can we specify this A or B in natural language? Every sequence of strings with one alphabets can be either A or B. That is the strings that can be formed out of this expression. And here A or B, it denotes this set. A or B. A can be followed by A. A can be also followed by B. Hence A and AB. Next B. B. First character can be either A or B. Hence B. B can be followed by A or B can be followed by B. Now you have this language. What about A star? We know that star will add a quantifier. It is quantifying the character that precedes it. So A star, even it's a regular expression, star indicates zero or more occurrences of the preceding character. So A star indicates this set. Since it is zero or more occurrence, epsilon is also a member of this language. Then we can have infinite number of strings. This is what we mentioned earlier. A language can have finite infinite alphabets, and using these finite alphabets, there can be infinite number of strings within that language. Let us continue with some more examples of regular expressions. A, B are the alphabets, and now we have A or B star. Just think about this expression. Is it possible to express this in natural language? You think for a while, then we will go ahead. See this, how these operators are formed. Then we should be able to spell that. Here, the sub-expression between the parentheses is A or B. That means either there should be A or B as the first alphabet, and how they can be recurred. They can be recurred or repeated in the string as per this star operator. Star indicates that zero or more occurrence of characters that precedes to it. The preceding to star is a sub-expression. And this sub-expression dictates that the first character can be either A or B. Hence, either 0 or more occurrences of A or 0 or more occurrences of B. Now, what will be the length of this character? Length of strings can be, we cannot predict that. What we can say is that since star is there, epsilon can be an element. After that, it is an infinite series. See 0 or more occurrences of A or B. Hence, epsilon A will become a member, B is a member of this language, AB is a member, ABB is a member, AABB, everything. Now this expression A or B star A. Think about this. What are the mandatory characters here? And what are the optional characters? And what will be the minimum length of this string? We can see that in some cases we can say, since epsilon is also a member, we cannot specify a minimum length. Is there a minimum length for strings formed out of this alphabet, this expression? Or can epsilon be a member here? A or B star A. Here, first alphabet of the string should be A. That is compulsory. And A is concatenated with a sub-expression called A or B star. Star quantifies how many times A or B can be repeated. 0 or more occurrences of either A or B after the first A. So first character is A. A is followed by 0 or more occurrences of either A or B. And that should be followed by A. So we will see that epsilon will not be a member of this string. And we can say that minimum number of characters in the string will be 2. Because since A or B star is put, star is 0 or more occurs of the preceding expression or element. A is a member. Between A, you can have any number of 0 number of A's or more number of A's, or 0 number of B's or more number of B's. A, C, A, B, A, then. Now, another expression. Epsilon or A followed by B. So this expression is concatenated with B, and B is quantified with star, and this entire expression is again quantified with star. Star represents 0 or more occurrences. Now this represents a language of several strings. First character. What is the first character? First character, let us see this, let us look at this parenthesis. We will see that it is, we can see the inner sub-expression. It can be either an epsilon or a, epsilon or a. Now epsilon or a is followed by 0 or more occurrences of b. Now this entire expression, can be repeated 0 or more number of times. That is the arrangement. Epsilon will be a member of this group. A will be a member of this group. Then what? Guess and tell me. What are the other characters? Is it infinite? Let us see a keyword called select in structured query languages. How a regular expression can be created to define the pattern for select. So we can see that in SQL, select is case insensitive. It can be specified in both cases. The sequence is that first character should be S followed by E, this entire sequence, without any spaces or other operators in between. How a RE can be formed to represent select? We go back to the pattern to be required. It is first character is S. Hence we will say that alphabets for this are S, E, L, E, C, D. Both uppercase and lowercase characters. Then we will see that it's a concatenation operator. S should be followed by E, E should be followed by L, then E, C, T. It is not case sensitive. We can have a combination of uppercase and lowercase characters of each of these. Then we have added OR operators on all these sub-expressions. So this sub-expression, these expressions together will provide the pattern for select. If an extra character is added and given this RE, it will say that it is not the select keyword. So this is how regular expressions work. We have to solve or see more examples in the textbook of, and we should see how a regular expression should be expressed in a natural language and how that should be expressed as an RE as per the given syntax of RE.